Okay, let's have one more inelastic collision problem. Number 9. In a game, Mikey is standing still when Crizel jumps from behind with a speed of 3.6 meters per second and landed on his back. Okay, assume that the masses of Mikey and Crizel are 70 kilograms and 50 kilograms respectively. What is now the combined speed of Mikey and Crizel? Okay, so we illustrate this. This is Mikey standing still, and then this is Crizel, okay, jumping. So the mass of Mikey would be 70 kilograms and Crizel would be 50 kilograms. Okay, so this is inelastic collision because initially they are separated and then afterwards, after collision, they are now together and they are having a combined speed. No? So the question is, what would be the combined speed? So we use the equation m1 v1 plus m2 v2. Initially, they are separated. This is before collision is equal to, now they are combined, m1, okay, plus m2 v prime. Okay, so the mass of Mikey is 15 kilograms, sorry, 50 kilograms, no, 70 kilograms. This is Mikey, this is Crizel. Okay, so 70 kilograms, but he is standing still, so V1 is 0. And then M2, the mass of Crizel is 50 kilograms, and he is heading towards Mikey. Let's make that positive. 3.6, okay, is equal to, the combined masses would be 120 kilograms. We got this from 70 plus 50. Then you have V prime. Okay, so we solve for V prime. You have 50 times 3.6 divided by 120. Their combined speed would be positive 1.5 meters per second. Okay, this is letter A answer. How much kinetic energy is lost during the collision? Okay, so uh, the kinetic energy before the collision must be equal to 1 half m1v1 squared plus 1 half m2v2 squared. Okay, uh, okay, so 1 half, the mass of Mikey is 70. This is 0 plus 1 half, the mass of Crizel is 50, and this is positive 3.6. Then we square this. Okay, so what is the kinetic energy before the collision? So 3.6 squared times 50 divided by 2, you get 324 joules. Of course, this one is 0. So this is KE before. What about the KE after they collided? Okay, so you have 1 half the mass, although they are together na, no? So this is 120 kilograms. And then the V1 prime squared, no? The V1 prime squared. Okay, let us see. We get 135 joules. So the KE lost would be equal to 135. Okay, it would be 324 minus 135 joules. So the KE lost would be 189 joules. And then we round this off to 2SF. This will give us 190 joules. Okay. Okay. Number 10, a 6.5 kilogram ball A thrown with a speed of 5.4 meters per second hits another 1.75 kilogram ball B at 2.2 meters per second in the opposite direction. What is the velocity of each object after an elastic collision? So notice that what we are given here is just uh, all the data before the collision. Okay, so we illustrate. Okay, there is a ball A which is bigger in size, heading to the right because this is positive, and there is ball B. It says here opposite direction. So we have MA, the mass of A is 6.5 kilograms. The velocity of A is positive 5.4 meters per second. The mass of B is 1.75 kilograms. The velocity of B is negative 2.2 meters per second. We are asked what is the velocity of each object after they separated, they collided, and then they separated. Okay, so the situation would be something like this. Okay, so there are two unknowns here. We do not know VA prime and we do not know VB prime. Okay, so in order for us to solve this, we have to use two equations. Let us first set up the first equation, which is total momentum before collision is equal to total momentum after collision. So the total momentum before collision would be MA VA plus MB VB is equal to MA VA prime plus MB VB prime. Okay, let us set up the equation. So uh, 6.5 times VA, which is 5.4, plus 1.75 times negative 2.2 is equal to, this is 6.5 VA prime plus, okay, MB is 1.75 times VB prime. We do not know that also. Okay, so let us highlight this. Okay, this is the first equation. We have just set up the first equation. Ito. Let this be equation 1. Now, where do we get equation 2? Now, you will be introduced to a new concept now, which is the coefficient of restitution. The coefficient of restitution is is a relationship between the final speed and the initial speed, the final set of speeds and the initial set of speed, and it is given by this equation. E is equal to negative the VB prime minus the VA prime all over the VB minus VA, and there's a negative value. So we have this. Okay, now let us use this equation. Okay, we know the value of VB and VA. We do not know VB prime and VA prime. Now for an elastic collision, there is a set value for E, and it's always equal to 1 for elastic collision. Okay, it says here elastic collision. So we can set up the equation. If E is equal to 1, therefore the equation becomes VB minus VA is equal to negative of VB prime minus VA prime. Okay, now VB has a value of negative 2.2 and VA has a value of 5.4. Okay, so we have negative 2.2 minus 5.4 equals negative VB prime minus VA prime. Okay, so this equation ends up as what is 2.2 plus 5.4? You get 7.6. Okay, this equation becomes VB prime minus VA prime is equal to 7.6. Now remember, this is negative 7.6. It will cancel with this negative sign. So you will end up with VB prime minus VA prime equals 7.6. Okay, so let us highlight the second equation. This is now the second equation. Okay, let this be equation 2. Okay, now we can perform substitution using your calculators. We can easily solve for VA prime and VB prime because we have two equations with two unknowns. Okay, so let us do the calculations shortcut now using our calculators. Okay, now using our calculators, programmable calculators, you would be able to solve for VA prime and VB prime. Okay, the values that you will get would be, okay, for VA, you're going to get 2.2 meters per second. This is VA prime. And for VB prime, you're going to get 9.8 meters per second. So these are the answers to VA prime and VB prime. Okay, let's go to the last problem. A 1.50 kilogram ball A moving at 3.0 meters per second collides with a 2.250 kilogram ball B that is suspended at the end of a cord from the ceiling. Find the maximum height relative to its original position that can be attained by ball B. Okay, so this is MA 1.50 kilograms, and this is VA, which is 3.0 meters per second. Okay, it's heading in this direction, and there is a ball B that is suspended on a string, no? And this must be at rest. Okay, so MB is equal to 2.250 kilograms. So ball A hits ball B, prompting ball B to move. Okay, so at rest siya initially. So let VB be equal to 0. They go through an elastic collision. They separated after they collided, no? Uh, so the question is, we have to solve for the speed VB prime to get the kinetic energy. And then it has all transferred to potential energy later on. So the question here is, what is VB prime after they separated? Find the maximum height relative to its original position that can be attained by ball B. No? So we set the equation. The total momentum before collision is MA VA plus MB VB is equal to MA VA prime plus MB VB prime. Okay, we are going to get we are going to set up this equation muna. Okay, now the problem particularly says that what is the maximum height? The maximum height will be attained when you have ball A transferring all its momentum to ball B. So, ibig sabihin, nag-stop siya. Kasi lahat ng momentum niya na-transfer. So, there are two cases here. Initially, ball B is at rest, so this equation will be 0. And then after they collided, all the momentum is transferred to ball B, so VA prime is at rest now. So, nag-stop moving si ball A. Although hindi sinabi sa problem, uh, explicitly, hindi obvious na sinabi nag-stop si ball A. Alam natin that you would be able to get the maximum height, okay, only when ball A stops after the collision. So, what would be the maximum possible height for ball B? Okay, so here we can solve for VB prime. Okay, so you have VB prime is equal to MA, which is 1.50 kilograms, multiplied by VA, 3.0 meters per second, divided by the mass of ball B, which is 2.250 kilograms. So what is VB prime? VB prime, you will get 2.0 meters per second. Okay, but we do not need this. We need this to solve for the maximum height. So the total kinetic energy, this is the maximum, will go to the potential energy maximum. Kasi ito magmo-move up, right? So you have 1 half mv squared, and in this case, the mass would be the mass of B, ball B, is equal to mgh. Now, the m and the m will cancel out. Same naman sila, no? So, this will cancel out. You can solve for h. So, h is equal to v squared over 2g. Okay, so the v is 2.0 meters per second. We square it, divided by 2, divided by the g, which is 9.8. What do we get? So the maximum height would be 0.20. Okay, okay, it would be 0.20 meters. Thank you.